Hello, I'm back. Um, Recently, I got thinking about how I spend a lot of time working on an engine, sort of. I spend a lot of time adding features to Squinchworms, and I think it's because, well, sorry, let me rephrase that. I spend a lot of time adding features to the code that I plan to use for Squinchworms. And so I never really get around to doing anything. I think the reason for that is because, for me, the most conceivable thing, the easiest thing to imagine how to proceed with is the engine work, actually. So it's sort of like bike shedding, I think is the term. Um, but recently I was watching a Mike Acton video and he was talking about practice. And I was like, yeah, that's kind of true. I would not be doing so much engine stuff if I was practicing instead of working on a some sort of long-term project, right? So with Squinchworms, because it's like a project that I keep around, I can sort of pretend, oh, this is going to be, later I'll work on the actual game, right? So I said to myself, why don't I practice? I'm going to do that. I just set a timer on my phone for 30 minutes, and I'm going to make this game in 30 minutes. And when I'm done, I'm going to throw everything I have away. And then next time, I'm going to do the same thing again, and we'll see how far I can get. So I just made a temporary directory, nothing in it, and we're going to copy. Oh, I forgot that my tilde key doesn't exist. I got a new keyboard. Worms practice. All right, so we'll unzip that. Uh-oh. Oh, what am I forgetting here? Sorry. I forgot some of the files inside of this zip file that was supposed to be a pre-made sort of, I don't know, environment for me to do work in. Forgot something. I don't know what I forgot. It's a dot file. Oh, you know what? It was the Clang format. Here, I'll grab that really quick, because I do care about this. Despite only having 30 minutes. Because I'll put it in the project for next time. This is one of those things that I'll keep with me. Okay. So let's go ahead and do build. I think if I'm going to do this quickly, my goal is going to be getting a little worm. Like a little worm will be a rectangle, and it'll have a little trail, and you'll be able to click, and there will be an arrow that will point in the direction of your mouse, and then you'll like launch in that direction. So let's make sure this. Yep. Okay. Great. Here we go. So I'm going to include chipmunk. I'm going to include, let's see, raylib, and I'm going to include my thing zig-like. Actually, I don't have a specific need for anything. Okay. So we'll go ahead and do an init window call. We'll do an inline const extra. I don't need inline. Const extra vector 2 screen size. So this is how we'll declare the size of the screen. We'll do x is like what, 800, y is 600. Cool, C++ 20. Initialization syntax, love that. screen size.x, screen size.y, and the title literally doesn't matter. Title. And we'll do while not window should close. We'll do our business, and then we will do close window. Okay, cool. So in theory this should open, so we'll do window clear. I forget how you do this. Clear window, maybe? Clear background, white. And then we will do, that's not what I want. Clear white. Oh, I'm gonna make this bigger so you guys can maybe see it. We're gonna clear white and we're gonna start drawing stuff. I need a camera. Camera 2D, camera. Let's do camera equals. Okay, so rotation 0, done. Zoom 1, offset equals. I wish, actually, I think I don't have to do that. Dot x equals screen size dot x over 2 dot y equals screen size dot y over 2, and then we will do target, which is 0, 0. So I think, oh, right, of course, it needs to be in the initializer thingies. Okay. Hello? Okay. So the camera's pointing at 0, 0, and we can move that around and do funny stuff with it. Let's go ahead and begin draw. Begin mode 2D. Camera. End mode 2D. Okay, that'll be our draw. Great. Okay. So we need a square. We need the ability to follow that square. Right. Okay. So this is going to require physics. So we need physics context. CP space space optional by default. Awesome. Space equals CP space new. That's fine. We'll keep that for the entirety of the program. CP space free space. Okay. We'll initialize physics before doing that funny stuff. Okay. Now we need to quickly, like, the concept of something that is drawable and also has physics. So we'll say square. And I'm gonna bring in my okay, so square is gonna have a body. Actually, we're gonna bring in chipmunk struct so we can store it by value. Structs, okay, that's the actual struct definition for stuff, so we'll do actual body. CP shape. We don't really want to couple those together. Okay, better idea. Should include vector. And we'll do a stud vector of bodies. So I'll stud vector bodies, and we'll excuse me? No, redo is the button that I wanted to press. Thank you very much. Okay, and we'll also do shape. Actually, I want these to be poly shape. Actually, let's quickly do like a... No, actually, I don't need to be doing this. I was going to make a variant for different types of shapes, but we'll just make everything be a poly shape. That will work out fine, I think. Oh, shit, but actually the terrain should be segments. Okay, we'll do this. Segment shape. Segments. We'll say polys and segments. And then we'll do an enum shape type. I think that Chipmunk already has one of these, but we'll make ours only a byte in size. And we'll say polygon segment. Okay, and then we will do... Does this need a... Yeah, okay. So polygon and segment, and then we'll have a struct shape. So this is a reference type. And we'll do shape type. And it also probably needs a pointer. Body. Actually, yeah, shit. CB bodies already definitely have... Oh, you know what? It can't be a pointer because vectors reallocate. Right, so this needs to be a... You know what, we'll just do a uint16t index. Okay, cool. And then struct body will be basically just an index, but it's not implicitly convertible index. Okay, so if I was being like really smart and cool, I guess I would make these types I would make these not public. So let's make a quick shape create shape. I guess I'm doing camel case now. So we'll do create poly, or no, yeah, create shape. And we won't have any way to destroy these shapes. We'll call this, I guess a better way to call this would be like shape level or something, because it, well, whatever, fuck, okay. I'm resigning myself to not being able to delete shapes, because if I have this index and I'm using a vector, that index would become invalid if I add it, if I removed anything from the vector. Well, anything besides the end, the item at the end. The vector is not a pool. So we'll do create shape, shape type. And we'll do if type. I'm gonna make this an enum class. Shape type polygon. Then we will do, okay, so unit t index equals 0. So if it's a polygon, then we'll do polys dot push back. What is happening there? No matching member function called a pushback. Does that mean? Oh, right, of course. Okay, so now we want to in place back the thing that I always use. Else huh? I did not spell that right. Segments. Okay. else segments dot in place back. Okay, great. But then we need to initialize it, so we're going to do cp poly shape init raw. Okay, so actually I lied. We want shape create box shape. Yeah, okay. And then we'll do polys dot in place back, and then we'll initialize that, so we'll do cp box shape init. So it's the poly shape, the body you want to attach it to, width, height, radius. Okay, cool. We'll pass in a body, and then we'll have a I guess wait, no, float width, float height, float radius. Yeah, okay. So real quick, we'll just add a get, which will just do return bodies index. Okay. Shit. I just remembered that they store they store pointers to these things, so actually we can't do this vector thing. I've got an idea. Oh wait, no, yeah. Better idea. Just make them all be arrays instead of vectors. Why? Huh? What's your problem? Oh. And then we'll say size t max things. Yeah, whatever, 256. Okay, and yeah, okay. That's fine. It's fine. Shit. Okay, so they need to grow. So then we have to do like a... Okay, we'll just do an index t, unit 16 t. Okay, so we're going to need something to point out the end of these arrays. Okay, so we'll need type name t, and this thing will be class thing. I'll just call it container. And we'll have a array of t max things, contents, and we'll have a sorry, I just realized I want to return a slice. Probably, I think, from one of these things. So, so we want to have a contents, and then we want to have an index t end. And then we want to have a public ZL slice t items, probably. Okay, so we want to be able to get all of the items, which is going to be return CL slice of T constructed from contents from 0 to end. Okay. And then we're going to want something to push back. So we'll go ahead and do, and we'll return a pointer to the thing. So we'll do pointer add. And so this function will do like, so we'll add to the end. Pointer item is contents data plus end, at end return item. Okay. And then we need so we want to be able to add. We don't really need to be able to do anything else, I don't think. I think that's enough, right? Because we're never going to remove anything from this. Okay, great. Okay, so container, huh? Container. Get rid of this. What is this? Oh, I spelled it wrong. Yeah, that's pretty funny, I think. Okay. So we got potties, poly segments. So create box shape. Right, so since we're storing pointers to the stuff anyways, and the pointers need to be stable, we can just get rid of all this stuff anyways. Okay, so we'll do pointer, create box shape. So we're basically doing C programming. I guess that's because we're using a C library, 2 C libraries. Let's see how much time we have left. 8.5 minutes remaining. Holy guacamole. All right. Return box init. I think, yes, box init returns the pointer. So just do a static cast. Yep. No, we'll do reference to shape. Okay. And then we'll do body, width, height, radius. Missing something though. Shape, body, width, height, radius. Right. So the first item should be poly shape polys.add. Okay. There we go. Okay. Okay, so that's how we create a box. Cool. Okay, and then we need to be able to draw the box. So let's start by just doing like wait, I've got a better idea. Let's make the floor because we're gonna need that. Create segment shape. And then we'll also make like a void draw segment shape. Do that in a second, and a void draw box shape. We'll take in a color Okay, should be good enough. So create segment shape. Turn CP segment shape init. Ah, okay, it is a thing. So pointer to the segment. Pointer to the segment, body, vector A, vector B, radius. Okay. 2 point A. Radius, okay. And then we will do segments.add body reinterpret cast. Wait, no, we'll just should make like a conversion operator for those two because they are exactly the same thing. Just two floats. Point A, point B, radius. What am I missing? Cannot initialize, right, okay. That's why we had the shape thing there. Okay, so we can create a segment shape. We can draw a segment shape by doing draw line V. Okay, so first we're going to need to do an upcast, so we'll do a segment, or downcast actually. Segment shape star segment equals cast shape. Okay. And then we're going to need to do vector 2a equals vector 2 pointer. Okay, and then dereference that. Just like an evil man. Okay, awesome. And so draw line V is from start and color. Okay, so A, B, right, and we'll take in a color. No, we'll just always do black, it's fine. Black, okay. Draw a box shape. We'll do, shoot. I don't think I have time. Okay, let's just see if we can get something on the screen. CP shape floor equals create segment shape. So it's body point A, point B, so we're going to do space CP space get static body space, and then it will be so it's a static shape, and it goes from negative screen size dot x over 2 to 0 all the way to dot x equals screen size dot x over 2, and y is also 0, and the radius is 1, let's say. And then we'll do draw segment shape floor. Okay, cool. Let's see if that works. Okay, that is an empty screen, and it doesn't close. Forgot something. Shoot. What am I forgetting? Oh, that was in nim. Shoot. Okay. Oh, the stupid raylib functions aren't here. While not, Windows should close. Okay, what does the main draw do? It does this whole texture mode thing. Begin drawing, end drawing. Maybe you need the begin draw and end draw calls. Oh. There you go. Alright. Let's see what we got. Nope. There you have it. A line. Physically simulated line. Alright. Could be worse. And I'm gonna go ahead and delete all of that. Not bad for the first day, I think.